It's a pleasure to be here. Thanks for having invited us to this panel. To start with, John Eckert covered brilliantly the subject. What we would like to address now, what we really would like to do in Portugal, taking into consideration the reality of the resources and the reality of the country, as it has been said. We all know that energy transition is unavoidable. I believe Portugal, yes, it is very well positioned for it. It has the know-how at the academia and at the industries. I just looked at what we are doing today in energy production. And today, up to now, in this day, we are producing 85% of our electricity with renewables, which is not bad. We'll have a peak load of 7,000 megawatts of load, and we'll have 4,000 megawatts of wind to cover, and on a rainy day, we'll produce 1,000 megawatts of solar at midday, around that, on a day where it is raining. We believe a lot on it. In my opinion, Portugal is walking the talk. It's not just talk, we are doing it. I think we are an excellent living lab for renewables because we are the right size. We are not too big. Everyone knows each other. We have a Portuguese part of the panel. We know each other for years, and most of the people in the room. I think we are the right size, and we can make the difference. I believe, I would love to see a FIDSAI of energy starting up on a Portuguese garage. And I think it will be possible. We have to expect for that. For this discussion, I'm not going on presentations, but we have here Brian, which comes from UT Austin and is head of energy. Ricardo is from the academia, from INESCTEC and from FILP. And João and Carla, they both are in industry. João at EDP and Carla at Galp. And I think both Galp and EDP are also walking the talk. At Texas, for instance, EDP, I believe, it's the largest operator of renewable resources, first or second, and third or fourth in the whole United States. Therefore, I think there are a lot of complementarities between UT Austin and Portugal. And if the fourth program goes forward, I think we'll have a lot to profit for the country, to make the difference there. And then, without speaking more, I pass the word to Brian. Brian, what I would like to ask you is the following. John covered very well the capabilities of UT Austin, and I was really impressed. You are head of energy. How would you manage all these capabilities to extract unique value for Portugal?
Yeah, I mean, John did a really good job of summarizing a lot of the big initiatives we have at UT. I think one of the phenomena that's happening in the United States right now is a real interest in what you might call a regional innovation engine. So this focus on regions and the unique resources and people and talents within those regions. Within the United States, you might think of Texas as a region, or even within Texas, so like the Gulf Coast, spanning into Louisiana or West Texas. So I've been director of the Energy Institute for a little over 2 years now, and so a lot of my efforts have really been focused on that model of regional innovation and thinking about a place like West Texas. What do they produce the most oil and gas in the United States, also the most wind, second in solar. And so if you think about an energy future, that also is like a living lab, for example. So I see so many synergies between what we're doing and thinking about at the University of Texas with respect to our region and the nation more broadly, the United States, and how that can link to Portugal, where we can actually learn from each other in terms of a hydrogen hub in our region is going to look different than a hydrogen hub in Portugal, for example. Okay. But there will be similarities in terms of things that are happening. So I think that there's not a direct overlap with the strengths and weaknesses of the two regions, but a lot of synergies, and a lot of the things I'm working on fit really well with what's happening in Portugal, and I would say vice versa.
Thanks a lot, Brian. Ricardo, I'll pass the word to you. I do believe, and most people say it, not inventing it, that the way forward in energy is bringing together ITC and energy itself, computing. You yourself has worked a lot on computing. You are a bit of a power engineer and a power scientist and a data science professional. You worked a lot of resources. On the previous UTOs, gave a lot of contribution to Portugal by introducing high-performance computing HPC in Portugal, by first donating Bob, which gave rise to the Callion. And I myself, as you know, I love computing. And what I would like you to cover now, it's as part of this present program, what we could bring into energy, having to do in computing. Specifically, you worked a lot on identifying resources, wind resources. You worked a lot on that. How could, I think it has not up to now been done using HPC. How could we make the difference by bringing HPC into resource evaluation, and perhaps being able to put many things in open source to make here a thriving community of people knowing how to do unique things?
Okay, thank you. One time I was invited for a workshop on HPC for energy, and I spent all the time explaining them what are their competitors, because there is always competitors to HPC. They didn't invite me again because I thought maybe it was not a good strategy. But I think we have to think HPC in two ways. So we see nowadays large language model. Everyone is saying that we need HPC because they require a lot of computational power to train. But I think that in the future the paradigm will be different. Nowadays, when we generate a numeric weather prediction, so we want to forecast the weather for tomorrow, or we want to map the wind resource in a certain location, use HPC intensively during some hours or days, and then we get a result. I think the future will be to use AI as an inference model. So you use HPC not to do these calculations every day on a daily basis, but to use it one time, you learn the model, and then you use the model in seconds. This is already happening in numeric weather predictions, where you are seeing that they are using the physical models to generate data. They are using an AI model that is learning on the top of this data. It's using HPC because it's very intensive computationally. But then you have that model and use it on the seconds base every day without need to retrain this. So we have to rethink the way HPC is doing. So it maybe will not be so intensive in terms of use. So the load diagram of HPC might not be a flat load diagram like it is today. So it needs to be more used in a more intelligent way. That's one thing. The other reason that I think they didn't invite me again was that
take care or will not invite you again.
They wanted to know what are the use cases in energy for HPC. And I think they were a little bit disappointed, because if we start thinking on those use cases, well, this was 7 years ago, there are not so many. CFD models.
CFD models is really important.
Only CFD. If we ask the ones we are operating, the Bob and the Callion, what are the clients, what they are using it, 90% is CFD models.
CFD modeling.
So we need to find new use cases for HPC in the energy sector, and there are new use cases. If we want to plan the power grid of the future, or the energy grid, if we consider hydrogen, we have to study future scenarios. Building scenarios, simulating scenarios, they take hours, days, and this means money. For companies, for example, it means a lot of money. So that could be a use case, is to think in digital twins, in the future of the future power grid, and help to design that. On the other end, and that's also a reason why they don't invite me, is because you have to think in alternatives. And we are starting to see physics-informed machine learning, which is a strong alternative to HPC, because allow you to do very fast simulation. You can go from days to minutes in different problems in power systems. So that's why I think HPC, they need also to start knowing exactly what are the requirements, what are their competitors, because there is competitors to HPC, and find ways or new use cases where you can really bring that.
Therefore, that would be an area to explore. Yeah. How can you best use HPC? For sure, there are many fields it can be used. What are the unique things you can do with HPC in power systems, using Portugal as a case study? Carla, you had innovation at Galp, worked a lot at EDP in the past in open innovation and so forth. You know a lot about this. Galp is an oil and gas company with a lot of knowledge on upstream and on platforms. And you were speaking yesterday that we are starting to put floating wind offshore, and you have much bigger structures. For that, that's a child's game, the small things we are doing in wind. What would you see that could be done between Galp and UT Austin?
Yeah, so first of all, thank you so much for inviting me for the panel, António and UT Austin. Well, renewables, I'm talking on behalf of an oil and gas companies, and we are giving the first steps into renewables, but renewables, they face a lot of challenges, the financial challenges, the dependence of China, the lack of skilled workers, and the network challenge. Let me pick on this one, the network challenge, because there is no energy transition without transmission. And the studies, they say that the world would need an additional 80 million kilometers of network so that the grid can observe all the electrons necessary for the energy transition. So this is a huge amount of investment. We are talking about billions of dollars, so it's massive. And downsizing this for Galp, and as I said, we are giving the first steps into renewables, but we are one of the leaders in PV installed capacity in Iberia. In Portugal and Spain, we have 11 solar parks. And one of the biggest challenges that we face is curtailment. And curtailment, for those that are not acquainted, is the incapacity of the grid to absorb the electrons that could be generated on that moment. So it means that the system is shut down. And as more bizarre that this can be, it is the reality. We have the panels, the technology, it is installed. It's not a matter of technology. It's not a matter of the willingness of the stakeholders to invest in renewables and put the projects into place and building those. But now we have a great amount of gigawatts of projects that are stopped waiting for grid connection. So this curtailment issue is a big thing, and it can be solved with energy storage. Of course, we can store electrons and then inject in the grid later on, or we can do hybridization, mixing solar and wind. But it's necessary to have accuracy in estimation of the curtailment, and I think that UT Texas, and a challenge for you, Brian, and the rest of the audience. This is a very practical and example of the pains that the corporate and stakeholders that are willing to walk the talk towards the energy transition are facing. So Advanced computing, modeling this is crucial so that we can understand the curtailment that we'll be facing for the projects that are already in place and the projects that are being built in the energy transition. And so you will be contributing not only to solve a problem of Galp, and EDP has the same problem, so everybody has problems with curtailment nowadays, but you would be contributing to achieving the goals of the energy transition globally. So, challenge for you.
Thanks a lot. João, you are the head of the head of the Center for New Technologies within EDP. Worked a lot on innovation. We worked together a lot in the past. Worked a lot in wind float and the most important projects of innovation within EDP. Just not to repeat things which have been said, picking a specific subject, how would you see nanotechnologies being used, which is a big subject of this institute you are in, a big subject of a big know-how of UT Austin. Do you see that EDP Portugal could use that know-how within energy?
Okay, thank you, António, and to fellow colleagues here, and thanks for the invite. Quick disclaimer here: we were being challenged today, so I think it's still today is still a bit the time we are looking for solutions, right? But still a time to diverge a bit.
Yeah.
I guess then we need to later on in smaller forums, etc., try to converge. But I mean, I think the way I approach this is still diverging. So
no problem.
Long list of ideas.
Feel free.
That's a bit my.
Feel free to think to.
Yeah. But indeed, I do think that nanotech is important, quite relevant, not only for EDP but for the whole sector. We need to build a clean, affordable, and resilient energy sector. Yeah. And I guess the point is that nanotech could touch each of these vectors or each of these concerns that we have in the energy sector. And I would like to go with some examples in each of these topics. For example, when we think clean energy, of course, big part of the equation will be solved by onshore wind and crystalline silicon PV, which is already mature technology. But I mean, we still need to go into different avenues. So, was already mentioned today, new, cheaper, more efficient, more flexible PV technology using new materials, for example. Or, for example, developing PV technology which is transparent. I mean, I'm thinking, for example, building integration, or, for example, agro PV. I mean, I was recently looking to a study from Wageningen University. They were looking at different alternatives of agro PV and the impact of transparency on the crops. Yeah. It is important. If we want to have a more benign industry and we want to have further access to land, etc., to develop renewables, I guess this topic of transparency would be relevant. On a different topic, for example, offshore wind is developing, floating offshore wind, so foundations for offshore wind. I mean, we know steel is expensive and concrete is also a possibility, but I mean, I guess there is room for composite structures that also bring costs down on floating technology. One other is, for example, we need to make our assets circular by design. We need to make sure that we produce less residues and that we are able to recycle in a more easier way our assets. So addressing nano to make sure that we can introduce this circularity by design. Or, for example, if we think demand, this was all supply. If we think demand, it was already touched today, but I guess this topic of electrification of heat and of industry, I guess for sure we'll need new materials that will facilitate that. And this is clean. Affordable, of course, this is a lot related, but for example, let's think green H2 or storage. We need to bring costs of green H2 and storage down. And I guess developing innovative coating techniques for the membranes themselves or for bipolar plates or for other components will be key to make sure that, for example, we use less rare, scarce materials because it's like iridium or platinum, these kinds of things. or, for example, using new chemistries that prevent the use of lithium or cobalt or nickel, which are, as we all know, have a bit of constraints as well. But I mean, and now a bit resilient. Let's say the last topic, resilient. I mean, the last thing we want is to move from a fossil economy, which depends on regions like Russia, Middle East, some areas in Africa, and move into a highly constrained area. And I don't know if you know, I guess you know, but let's say I have some notes here. Top 3 nickel producers are Indonesia, Philippines, and Russia. The top 3 for cobalt are Congo, Indonesia, and Russia. 70% of cobalt and lithium processing is in the hands of Chinese companies. 97% of PV is produced in China. So I guess it's a bit, of course, part of the solution will be these solutions of nearshoring, etc., trying to produce these conventional PVs in Europe in order to break these chains. But as well, I mean, developing new technology, which is native from Europe, will for sure help us in this path. I'll stop here.
Thanks a lot. Brian, I've been following innovation in Austin, and Austin is becoming a thriving hub for innovation. Yeah. How could UT Austin help Portugal make use or leverage on that capability of Austin in such a way that, as I said in the beginning, we have some expectation that the feed-die of energy, or better, the windows of energy starts in a Portuguese garage?
Yeah, I mean, so I think the UT Portugal program has actually done a really good job of that. Going back to the beginning of the UT Portugal program, you know, part of the program was talking about technology transfer and how to do that process, best practices, and a lot of those processes were adopted in Portugal, and then the U10 program that Marco Bravo led. I think from what I've seen, there's been a lot of synergies between UT Portugal program, innovation that's happening in Austin, especially with, you know, the involvement of IC Squared Institute and all of that, and what's happening in Portugal. So right now, it's really interesting in Texas with energy innovation. You have venture capital, startups that are trying to transform the energy space, but then you also have a lot of capital coming in from the incumbent energy industries. So Shell, Chevron, ExxonMobil, you know, they all have venture groups as well. So in Texas, the innovation, I guess the mindset in Austin tends to be very startup focused, maybe not so much the venture capital from incumbent energy companies, but we've got the headquarters of Tesla there. We have several startups, like there's a company, EnergyX, that's raised hundreds of millions of dollars doing lithium extraction. So those sorts of companies. And then we have a lot of interaction with Houston. So in Houston, the innovation ecosystem is a bit different, where that's where a lot of the incumbent energy companies are really putting in money to startups. There's an incubator called Greentown Labs there, and we have programs with them. So I think the interesting thing for a UT Portugal program is actually bringing a bit of that mix of what is happening in Texas, where you have the kind of an Austin startup mindset, but then Houston's rebranded themselves the energy transition capital of the world, which is really interesting to me. But so you have all of this capital, you have places to actually deploy technologies and pilot them within Texas, and I think, you know, we could learn from each other. So Texas and Portugal, and I think bringing those very different models of how to do energy innovation. And a startup might not be the only way to do it. You know, it might be better to actually interact very closely with an incumbent energy company to make that breakthrough, that technology breakthrough.
Thanks a lot. Ricardo, energy, as it has been said by John, has a huge connection with economic growth. And there are, as John said, big inequities In the past, and we have addressed this problem. How could Portugal help developing countries develop some independence in energy? How do you see that this could tie with the problem?
Yes, I think this should be actually a priority for both countries. In US, there is initiative which is Justice 40, which is energy justice. Is exactly how you, it's more than mitigation energy poverty. Is how you create local economic conditions for people to sustain. That, of course, is based on access to electricity, but not just that. We can create circular communities where around renewable energy you can have water, you can have people that get just their job that's just maintaining the PV panels, for example. So we can create a local economy at the community level that can be circular in terms of uses of resources, use of waste, and so on. But I'm a former outcome of these international collaborations, because I made my PhD with MIT Portugal program, and I learned there only two things. Not so much, but only two things. One is energy is local, and the second one, you need to have a systemic view of things, a system view of things. I have the tendency sometimes not to understand why we are investing in large-scale renewable power plants, that we have to bring all that generation to the large consumption centers using transmission network. We have to reinforce transmission network, something like this. If we want to go to developing countries, don't bring that notion and that idea. We need to do a bottom-up electrification. We need to look at local communities.
Microgrids, and all the technology needs to be invented.
Exactly. So the thing is, should they have a microgrid isolated? Should we connect them to the main grid? Should we build a mini grid?
Mini grid with several villages.
So I think this is a big challenge. In terms of technology, but not just that, social acceptance of technology, maintenance of technology is always a problem. In developing countries, maintaining the assets, they normally are abandoned. We made one project 2 years ago with Africa, and what they're saying, okay, these European companies, they come here, they install a PV power plant, looks very nice, and then they simply abandon the asset. There is no maintenance, it's no longer operating. So we have to think on supply chain for all of this. So that's one thing, and I think we should look at this. Also, something it's related with the topics that still exist in this international program is remote sensing. If we want to do this, we have to rely on remote sensing to plan everything without going to the field, because there is costs, and plan exactly, for example, how far a village is from the main grid, what kind of options we have. So I think this is important. It's very aligned with what is being done in US for the energy justice, and I think in Europe we miss something like that, and the ties we have with developing countries are much higher than other countries, in Portugal in particular.
Thanks a lot. I do agree with you. It should be a very interesting area. Changing completely the subject, Carla, now it's for you again. Changing the subject, one of the strengths of UT Austin is satellite remote sensing. Would it be usable by Galp, that capability? What could be done? How could that be leveraged within your company?
Yes, definitely. So satellite observing is something that could be useful for an oil and gas companies, and most of it if they are investing in renewables. And I will share with you something that happened 1 month ago. 1 month ago was summer. So Spain, Portugal, we were having 30 degrees every day. And we had a severe weather event with hail, like balls this size, that destroyed 80,000 PV panels. So the loss is huge. It's the financial loss, because it's energy that we are not producing. We have 2 parks that are completely stopped. We have the the financial loss of replacing 80,000 PV panels, and of course the environmental loss, because recycling PV panels is something that is not completely studied, or of course they are recycled, but materials, what can we do with materials? The spare materials is not completely clear for us as well. So weather forecast, we are talking about weather forecast. So satellite tools that could complement the ground-based tools, that would be crucial for us. So this is an important thing as of today. We have a task force team that is looking for the best solution to not to prevent, but as a warning system that could tell us in advance that this kind of weather events are going to happen. If we would have known 2 hours in advance that we would have this event, we could have time to rotate the panels into a vertical position, and this would avoid all the damage that we had. So obviously, collaborating with people that are acquainted with this topic, people that can help us here understanding the best solutions to have warning systems and advise us or provide us with the best solution, that would be, of course, very interesting. And for those that don't know, Galp works a lot with institutions, with academic institutions. We work a lot with INESC-TEC. We have many projects with them in collaboration when we need areas of expertise that we don't have. And this is another example of where we could collaborate. So weather forecast, accurate data, again, tools that I think you are super expert in, and we are not. So another example of collaboration between the corporates and UT Austin and Portugal.
Thanks a lot. João, you worked a lot in green hydrogen. Namely, you helped put together HyLab, which is the collaborative lab for hydrogen in Portugal. John mentioned a lot, and it makes sense, blue hydrogen. How do you see both things could come together, and how it could be useful be unique for Portugal? Betting perhaps not putting every coin on green hydrogen, but also betting on on blue hydrogen.
Okay. I mean, I guess there was this question from the audience which was addressing this issue in the sense that, and I guess what John replied is what I also think is depends a bit on the resources you have. I mean, for a nation like the US, it makes sense. You have lots of available resource, but I'm pretty sure that Portugal has an advantage to go deeper, let's say, directly to the green avenue, rather than spending too much resources on, let's say, on blue hydrogen. I mean, and I guess this green hydrogen is I would say it's a win-win in the sense that for one side, it will help us to decarbonize let's say the ones which are harder to abate, the ones which are harder to electrify, high heat processes, etc. On the other side, it's also beneficial for the energy system as a storage or a energy vector that could accommodate variability of renewables and as well curtailment, which is kind of a variability as well, but curtailment that Carla was explaining a while ago. But this is it, and I do think that UT Austin for sure has strong capabilities here. Just the fact that you are in Texas, and this being a gas and the pipes business, I would say even geographically puts in the right place. So I would like to come with a couple of ideas, suggestions where we could perhaps try to direct our cooperation. One is like it perhaps it's more usual to start with hydrogen production with electrolyzers, but I mean the first is just a thought, but let's not overlook the supply, let's say the demand side. So things that need to happen on on industries, on electric vehicles, be it light or heavy, so that we can use hydrogen through fuel cells or through combustion engines of hydrogen or other carriers. But I mean, what needs to happen on that side? Other is thinking about, let's say, these computational capabilities of UT Austin. For example, you mentioned iLab when we were discussing what should be the focus of iLab. Where could we differentiate? Because I mean, a lot of people, Fraunhofer is working on electrolyzer. I mean, a lot of people is doing many things. So I guess one of the avenues of focus is come up with the strong computational skills and the digital twin so that we are able to properly model all the elements of the value chain. And this will have, of course, impacts on, I mean, be it on planning or decision of investments, on the design of the systems, or, for example, trying to look what are the, let's say, the right renewables mixes at every time to make sure that we run the electrolyzers properly. For example, we could model PPAs with clients vis-a-vis what's happening on the market to see what percentage we should buy on the market, what percentage we should buy on the... so it has a lot to do with optimization. Not sure if this is that we require all this computational power that you guys have. But for example, if you bundle this with CFD, then I guess the problem becomes of a different kind, and perhaps this big computational power that you have may be, I guess, a differentiator. Third idea, you mentioned a lot of curtailment. It's happening in Iberia frequently. Not sure if it's, let's say, to stay, but I mean, at least I see...
As two components. One is global at system level, yeah. Another one is at nodal level.
Yeah.
There are two different challenges.
I think that one thought I have is, for example, I mean, curtailment will always tend to grow a bit in the sense that renewables, even though there are hurdles to development, they develop somewhat fast, and storage and green energy will come at a slower pace.
Yeah.
So if we think of these vectors as a way to accommodate curtailment, I mean, there will always be some growth. But the point is, curtailment is growing. We saw also recently on the news, for example, manufacturers of turbines saying that they are already able to run turbines on 100% hydrogen. I think they can go up to 50 megawatts already. And I thought there are many talks of people refurbishing their bigger plants, CCGTs or gas plants, with higher quantities of hydrogen being on co-combustion with gas. So my challenge was a bit, why can't we look at our CCGTs? We have a couple. If we think Portugal, if we think elsewhere, we have more. And really think seriously on high volumes of incorporation of hydrogen in our CCGTs. I mean, I think we could even aim for 100%. There are for sure challenges, be it on nano, be it on modeling, but I mean, I think it's a good challenge to have to address it. I mean, and still, one final, also going around high lab, etc., and asking what are some challenges. I mean, there are some other stuff that people think, for example, and this I think relevant for UT Austin, but as well INL, where we are, thinking at the capacity to increase the contact area of membranes, to increase the catalytic effect, to make sure that we improve the efficiency of the electrolyzers. I mean, there are many things. On the electrolyzer levels, for example, we saw electrolyzers like the solid oxide ones with very high efficiencies, but then they have issues with degradation of the stacks, and they have issues with flexibility. So perhaps trying to solve this equation as well.
Yeah. Can I add a few?
Of course,
few ideas?
Of course.
I mean, so I think the opportunities to combine what we're going to be learning in our region for hydrogen and what Portugal will be learning are immense. So in our hydrogen hub, you know, people think of it as being a blue hydrogen hub, which is, you know, natural gas hydrogen, but actually 40% of the projects are green hydrogen and 60% are blue. So it's actually a mix of the two. And so there's going to be some learning, like some comparative learning between, say, you know, prices of electrolytic hydrogen and all of that versus from natural gas. But the once you make the hydrogen is one thing, but then once you have the hydrogen, a lot of the aspects of hydrogen are the same. So what are the markets? What do you use that for? Are you going to use it for trucking? Are you going to use it to power forklifts? Are you going to pipe the hydrogen around? Where do you make the hydrogen? Do you try to make it near where you're using it? So you take the electrons from wherever your solar farm is and do that, or do you try to make the hydrogen where your solar farm is and then build a pipeline? So transport, those issues will be similar. The other thing we have a lot of research at UT on is geological hydrogen storage. So salt domes so if you have a lot of salt domes in Portugal, you're perfect for geological hydrogen storage. And there are a lot of questions about once you put hydrogen in the ground, are there bacteria and things that eat the hydrogen? You know, does it leak? There was a question about leakage and all of that. So how you store it, what are the markets, where do you use it? I think in Portugal, you have the potential to export hydrogen. So, you know, do you export hydrogen to a neighboring country like Morocco, or do you convert it to ammonia here and export it? So all of those questions are, it doesn't matter whether it's green or blue. And so those are some things that we're going to learn about in Texas that can transfer to Portugal and vice versa.
Thanks a lot.
Just quick, Evan. No, I mean, just to
time is running. Time is running.
Yeah, it's quick. to fully agree, because I mean, the let's say the cost challenge or the cost decrease challenge for electrolytical hydrogen is huge. I'm not sure if people are aware. We've run some calculations in some, for example, in some specific systems, looking at the reality of some specific systems and using the curtailed energy of specific systems, let's say small systems. And I mean, we reach prices at 20 euros per kilogram. And the target you showed, it was €1 per kilogram. Right. So, I mean, at some point in time, in order to create an industry, I mean, of course, I understand that we should delve into the blue hydrogen world as well.
Well, with cost, there might be some policy lessons to be learned as well. So, I mean, in the United States, green hydrogen will compete cost-wise with blue because of the Inflation Reduction Act and things like 45V and, you know, that sort of thing. So I think there will be learnings in policy that could be adopted in the European Union or maybe in, you know, vice versa in the US. So that's another thing.
And I pass that for Ricardo to comment. How could we learn from the IRA, from the Inflation Reduction Act, and try to find spillovers to Europe and to Portugal?
I think it should be bidirectional, because some things they are doing in IRA, it's not a good name actually. We already have been doing this in Europe for some years. One example is decarbonization of ports. That's something that is in the agenda in IRA, but in Europe is already being done. Actually, it's a very interesting case study, because ports, they are like a city. They're a big ecosystem, industrial ecosystem, and to decarbonize them, we need collaboration between the companies that are inside those ports, which is sometimes not so easy, because sometimes we have even the whole supply chain inside the port. But that's something they have in the agenda, and I think in the case of Europe, we are more advanced, and also on energy efficiency at the consumer level. Europe, the manufacturers of smart appliances, they are very well advanced, and in particular on thermal loads, which is something that is also a priority, I think, in Europe. But on the other way, I think we end buying electrolyzers to US, because the technology in US, they have more funding or access to funding to further develop the technology up to the 1 gigawatt scale that I don't think in Europe will have it.
Scale up, as it had been mentioned before on the previous.
But in US, they are more advanced, and I think we have a lot to learn from technology, and also in line with what João is saying, because we might work in other things related with hydrogen, not the technology itself, but the digital twin, the supply chain optimization, and so on. And I think they have there, and we are talking here, and we can hear the rain outside, is extreme weather and the protection of critical infrastructures. And I think we used to see in the US all those thunderstorms and hurricanes, and we thought, okay, the Azores, sometimes they were affected by that, but we were quite okay. And now we are seeing it here in Europe. And not just in the Atlantic coast, we are seeing fires in Sweden 3 years ago, and those kind of things. So protection of critical infrastructures and modernization of these critical infrastructures is something that is key, and it's not just the infrastructure itself, because behind all these infrastructures we have humans, and those humans, they are policymakers, they operate the infrastructures. So we need to have this transversal view that goes from the technology up to the humans who make the decisions, who operate the networks, so that resilience is not just something we use as a buzzword, but it's something we fully integrate on human decision making, in addition to all the technology, of course.
Therefore, critical infrastructures could be an interesting area to try to cover.
I'm trying to sell these all over Europe, actually.
I'm buying.
But and in the US as well, because we have a working group with US, and the main topic is critical infrastructures. And we are actually coordinating an EU project for AI applied to critical infrastructures, not just electricity. We are talking about mobility, railway and air traffic management, where the level of congestion we have in airports, it's not just Lisbon Airport, it's everywhere. So we are going in this direction where we need to rethink the way we operate these infrastructures to be not just resilient to weather, also to other factors like this underinvestment. That's another problem. Like curtailment of renewable might be a consequence of underinvestment in infrastructures.
Thanks. Carla, coming to one of the core business of Galp, which is mobility, how do you see that mobility has to change from what it was to the future, more electrical and so forth? How do you see it, and how do you see it within the program? I think it had a great fit with energy. How do you see that?
Yes.
One of your core businesses could benefit from this.
Yeah, so mobility is our core business forever on a carbon fuels way, but now we are shifting to electric. But before I go back to mobility, to the mobility topic, if I may, just to complement the hydrogen challenge, we are doing a great work in sector coupling in the hard-to-abate industries, and how can we help our clients to decarbonize? So we are actively, proactively picking up the hard-to-abate industries in Portugal and try to have viability studies in place to understand what can be done technically and financially is viable for those clients, and us as an energy provider, because it's our core business. It's not only fossil fuels, but nowadays it's more than that, much more than that. So how can we help them, and the solutions that are more interesting for them to adopt and to invest in? But going back to mobility. So mobility, or electric mobility now, it's a completely game changer. So we have integration of the systems, we have the electrification of vehicles, cars, trucks, wherever, and the business models are changing a lot. So we have autonomous vehicles, we have last mile logistics. So the way we are moving people and objects from point A to point B is changing a lot. But the experience in driving EV for the end user is not there yet. It's not there yet. I drive an EV. It claims 400 kilometers autonomy. In our way, it's less than 300. So it means that I have to stop when I'm driving from Lisbon to Braga, and I'm okay with it because I only need to charge for 15 minutes. So it's nothing that I cannot adjust in my trip. The thing is, when I stopped halfway, I had 3 cars in front of me. So I had to do my calculations. If each one of them is staying there for 20 minutes, it means that I have to wait 1 hour plus my 20 minutes, 1 hour 20. For a trip that takes 3 hours and a half is 30% more. It's huge. So we are driving from point A to point B without knowing our ETA. So it's going back to the old days where we don't have roads and cars, but now with all this technology, and the data is there. So and institutions like yours that have an amazing experience and knowledge in advanced computing and neural networks and digital twins, I think that this could be solved because the data is there. Well, if I have people queuing in a charger, the data is there, so it needs to be collected and it needs to be shared through the system so that my car knows that on that charging point that I'm planning to stop, probably it's not the best charging point to stop. So the car should reroute itself and advise me to stop the station before or the next one. So I think there is so much things that can be done in data science. And again, Galp, we have amazing geologists and chemical engineers, but data science is not our thing. So why don't we make an effort for all the network of smart mobility to have more information? Because without information, the electrical mobility early adopters will have a bad experience nowadays. I'm not talking about driving in cities. I think it's an amazing experience. I love driving an EV, but for long distance drive is still painful. So another challenge from the corporate world to UT Austin, Portugal. I think a lot of research, a lot of modeling the future can be done here as well.
Thanks a lot. Please, an applause for them.